So this problem has two parts to it. So we want to know the acceleration of the elevator. So what they give us is the tension on the elevator, the mass, the velocity, which is kind of hard to see here, but it's 1.2 meters per second upward, and the time, which is 4 seconds. But the initial velocity and the time we won't use until part B. So I have a free body diagram right now up here. So you can see that the mass and the gravitational force is pulling down on it, which is the weight, and the tension is pulling up because string and like tension, it can only pull on an object, it can't push. So therefore it's acting upwards on the elevator. So therefore we know that the T, which is positive, and the weight mg is negative, so we know that is equivalent to the acceleration, F equals ma, which is equivalent to the force, which is F equals ma. So all we have to do is we just have to rearrange this equation to find A, which we know would come out to be T over m minus g equals A. Now we just plug in the formulas for T, the number for T, and we plug in m, and we minus 9.8. Now the reason this comes out to be meters over second squared is because a Newton is equivalent to kilogram times meters per second squared. So when you divide by a kilogram, when you divide a Newton by a kilogram, it actually makes it meters per second squared, which fits right with our acceleration, and it means our acceleration is 3.5 meters per second squared upwards, which makes sense because the elevator is moving upwards. So that's its acceleration. So for part B, it wants us to find the final velocity. So for the final velocity, we have to take the initial velocity, which is the 1.2 meters per second squared, and then add it to the acceleration, which is 3.5 meters per second squared, times the time, which is 4 seconds, and that will actually give us Vf equals 15.2 meters per second upward. And the reason you add the velocity and the acceleration times the time is because we know that acceleration is equal to the change in velocity over the change in time. So if you rearrange the equation, it's actually, you basically would add the velocity from the Vf minus Vi, and you would add it to the other side, and that's how you rearrange the equation. So it becomes, like the first step you do would be Vf minus Vi equals the acceleration times time, which is simple algebra, and then you just move the initial velocity, and that's how you get this equation, and that gives you the 15.2 meters per second upwards, which is the right units for velocity, and it also makes sense with our acceleration. So that's how we can double check our answer and know that it makes sense logically.